Welcome, ladies and gents. This is Mr. Anderson. We are in section 2.3.2. It is the last section, the last day, the last unit, the last digital distance delivery of our linear relationships unit for our CPM Common Core Algebra text. All right, we're going to focus today on an additional way to write the equation of a line that focuses on different given information. All right, and that different given information is going to be writing an equation of a line, and we're going to use slope-intercept form again, but we're going to be given 2 points. And what I have, I'm going to walk through one thing with you. I'm going to give you a chance to try some things. I'm going to show you what it looks like. But what I have is a set up, systematic, step-by-step process that is going to help you. All right, check this out, ladies and gents. We're going to start with 2-87, and this, as I mentioned, is coming from section 2.3.2 of your CPM textbook, and you can be given 2 points many ways. In this particular problem, we are given 2 points in a table. Actually, we're given 5 points in a table, but 5 is, of course, at least 2. All right, we've got X's, we've got Y's, we've got inputs, we've got outputs, and they're all given, they're all given right here. What I'm going to go ahead and do is I'm going to go ahead and pick 2 points out of this table. Now, the 2 points that I'm going to pick are right here and right here. Now, this might be guessable to you, but in the event it's not, the reason I picked these 2 points is twofold. Number one, they're non-negative. We're about to do some math with these numbers, and I know that if I do math with numbers that aren't negative, it's going to be math that's easier for me. The second thing is, in addition to being positive, they're reasonably small. And I know what you're thinking. Oh, Anderson, 64 and 52, they aren't that small. Yeah, but the alternative was 2997. Okay? And I don't want to be messing with that when I can be dealing with some smaller numbers. So that's what we're looking for. We're looking for numbers that are reasonably small and numbers that are positive. And we're going to go ahead and start by finding the slope. And this should be no unfamiliar process to you by this point. All right, we're using this formula that we've been working with quite a while in this unit and in class, and we're going to go ahead and identify what x1 and y1 and x2 and y2 are. And I like labeling those things for the purposes of organization. x1, y1, x2, y2. And as we've mentioned already, it does not matter which points you picked. So if you wanted to go with the negative points, you could. If you labeled them in a different order, that'd be fine too. But ladies and gents, even though your process might be different, your product should be the same. So let's check. All right, y2 minus y1, 52 minus 64. All right, divided by x2 minus x1. That's going to be 14 minus 18. All right, now if you need, grab a calculator, but 52 minus 64 is negative 12. 14 minus 18, that is negative 4. I know that a negative divided by a negative is a positive, and 12 divided by 4 is 3. If you like 3 because it's a nice whole number, great. If you like having that in rise over run fashion, you can write it as 3 over 1. Either one is going to work out just fine for you. All right, step number 2, step number 2, part B, I'm sorry, I kind of already hinted at. All right, and maybe you caught it, but if you didn't, let me be explicit about it here. It asks, does it matter which points you use to find the slope of your line? No, and I'm going to elaborate more on this later. All right, but it says find the slope with 2 other points to verify your answer. So now watch this, ladies and gentlemen. I'm going to go ahead now and I'm going to pick 2 points that are not as easy to deal with. I'm going to deal with some of these negatives. All right, I'm going to do the exact same thing. I'm not going to write out that formula again. I've already got it. x2 minus x1 divided by y2, I'm sorry, I said x2 minus x1, y2 minus y1 over x2 minus x1. Let me see here, negative 27 minus negative 8. All right, if I go ahead and work this out, oh man, I'm dealing with some negatives. If I need, I can grab a calculator. All right, but this is just like saying negative 71 plus 14, and on the bottom this is going to be what, negative 27 plus 8, And if I work this out, that should be, what, negative 57? And on the top, let's see, or on the bottom, let's see, negative 18, right? Negative 19, I'm sorry. Then this might be the hardest part. And this is something I am going to just verify with the calculator, because why make a mistake if I don't need to, right? Give me just one moment. I got to make sure I did that math accurately. Hey, I did do the top right, but now I got to divide. What is 57 divided by 19? Holy cow, that's also 3. My goodness, can you believe that that actually checked out? Just goes to show you that even sometimes some of these simple processes, right? Some of the people we perceive to be excellent at math, right? We still need a little bit of help, and you're no different than me maybe in this case. Maybe you needed to grab a calculator too, letting you know that that is okay. Now, how can we use a point to find the equation and find the equation of that line? Ladies and gents, this is what we did in our last video. We're going to go ahead and remember that y equals mx plus b format. We're going to sub in any points. Remember, I like the points that are positive and small, if I can have them. So what is the smallest positive point that I have? Whoops. I wanted the eraser. Sorry about that. The smallest positive point looks like it's going to be 14 and 52. So I'm going to plug in 14 and 52 for x and y. So 52 equals 3 times 14 plus b. Okay, let's just talk about this. This right here was a x value from my table. This was a y value from my table. And this was my slope from part B. Or A, I guess. Doesn't matter. Now, let's do the math here. 3 times 14. Holy cow, I think I have that in my head. 3 times 14 is 42 plus B. Now, this might be manageable, but if not, grab a calc. Subtract 42 from both sides to get the b by itself, and when you do so, you get b as 10. Okay, now if you stop there, you haven't really written the equation. We want you to take it a step further, and we want you to plug m and b back into the equation of the line. So it's going to be y equals 3x plus 10. All right, there is my equation. Okay, now D says once you have the slope, doesn't matter which point you use to find the equation, why or why not. And this is something that I hinted at earlier, and now let me be explicit about it. And the answer is going to be absolutely not. No, it does not. And you're saying, why, Anderson? Why not? Because all of these points, remember how we did in A and B, we found the slope between 2 points and we found the slope between another 2 points, and the slope was the same. All of these points get from one to the next by rising 3 and running 1, rising 3 and running 1. All of these points lie on the same line. Okay? So they're all going to make that equation true no matter what. All right? All of these points are going to lie on that line. Anytime we plug in an x and a y, we use the slope, multiplied by x to get y. And that's going to be the difference there when we take y and subtract the slope times x is always going to be that intercept, okay? Now, part E is, I think, in this particular case, the cool part. And if you notice over here, I've got a Desmos window set up, and the Desmos window, I think, is going to really do some cool things for us here and shed some light on what it is we're doing. Check this out. If you've never used Desmos before, Desmos.com, click Start Graphing. It's really a pretty nifty thing. I can go ahead and I'm just going to start typing in some of the points that I have from the, what's this called? The problem, 2-87. First, it gives me 2997. And then I can enter in the next point. It is 18 and 64. And then I can enter in the next point, -8. Oops, I've got to get the parentheses in there. -8. And then -14. And then there's two more. Bear with me just a moment. 14 and 52. Normally I have these things done ahead of time, but I really wanted to show you guys that you can enter in some ordered pairs. As long as we're typing correctly, we'll get these things to show up. Let's see, negative 27 and negative 71. Now right now you're going, oh Anderson, I can't see those. Well, I do have to zoom out so I can see these guys. All right, and there we go. We can kind of see them. And it's really like looking kind of cool because I can kind of see these things on this linear trend right here. It looks like if I was to hold up my ruler and draw a line, it would kind of connect all those dots. But let's verify that I did this correctly. And the other way that we can do this is to verify with our equation. Now what I'm going to do is I'm going to type in my equation. I'm going to graph it. The equation that we wrote in part C, I'm going to graph it. If it goes through all those points, then we nailed it. If it doesn't, we've got a problem. So let's check it out. Y equals, and I'm just going to type this in exactly like I wrote it in slope-intercept form. Y equals 3x plus 10. And ladies and gents, whoa. All right. What do you know, right? I can zoom in, and I can check out any point, and that line is striked right through those points, right? Right through there. Okay? So that's one way that we can verify it. We can, of course, check the, by plugging the X, we can verify that the Y comes out. There's quite a few options. Obviously, the fun and easy one is to use some technology. Okay? So there you have it, folks. There's writing an equation from 2 points. In this particular case, we have 5 points, and maybe the hardest part for you was picking 2. There is a tiny bit of review preview associated with this lesson. It is going to have you trying some of these things, and ladies and gents, I believe there, if you want to check, let me just give you this advice. If you want to check this, use Desmos to check, because Desmos is going to have the precision and accuracy. Don't try to check this by graphing by hand. You may not be accurate enough and find you're unintentionally thinking you made an error, okay? So if you're going to check graphing, using graphing, please check using Desmos, okay? Ladies and gentlemen, thank you for watching. Have a great day.